Okay, so for me it's 2:15 now, so I'll get us started. Welcome to this session for today. Welcome to this session as part of Global Azure. First of all, I want to thank the organizers of Global Azure, really an amazing initiative. I'm very happy to be able to join today. I'm very happy to be able to share with you some content around Windows Docker containers. So with that, I'd like to get us started. As you can already see, the company I work for is Cosmo Consult, and I want to thank them as well for allowing me to join today. My name is, first of all, the introduction. What are we going to talk about? We're going to talk about how you can get started with Windows containers using Portainer and Traefik, and for that we will use an Azure VM. So basically, this is a get started session around Windows containers to help you if you don't want to do the installation on your own, if you don't want to get started on your local machine, maybe break anything or run into any issues that might happen for you locally, but instead, just use an Azure VM that you can easily throw away afterwards and do with it whatever you want. You can see the agenda on top. So we're going to do a quick introduction to containers for those who don't know what containers are. We're going to do the Azure VM deployment so that the VM is up and running. And then we'll take a look at Portainer as a management tool for containers and at Traefik for the networking. So to first of all introduce myself, my name is Tobias Fenster. I'm the CTO for the Cosmo Consult Group. We are a Microsoft partner across the whole Microsoft portfolio, working in Europe, in Asia, in Southern America, also with partners across the globe. I'm a dual Microsoft MVP for business applications and for Azure, and also a Microsoft regional director. That doesn't mean that I work for Microsoft, although it might say may sound like that, but instead it just means that I'm part of another program for Microsoft similar to the MVPs. Also, I'm part of the ambassadors program, both for Traefik and Portainer. And if you like what you're seeing today, if you want to follow what I'm doing, then you can find my Twitter handle, the URL for my blog, as well as my LinkedIn URL here. So with that, I'll like to get us started in the topic itself. The first part will be the introduction for containers, especially for Docker. So for those of you who already know, this might be a boring, 3 to 5 minutes. But for those of you who don't, this should help you to follow for the rest, and I'll keep it brief for those who already know a lot. So what is Docker in theory, or what is Docker to start with? Docker is the most widely used containerization platform, especially for Windows. It has a lot of usage on Linux and Mac as well. There are, of course, also alternatives, but especially if you're coming from a Windows background, then I think if you want to go into containerization, then Docker more or less is your only option. What is a Docker container? What is a Docker image? The image is the template, so kind of the recipe that you need to create a container. It has the minimum amount of the operating system, the libraries, and the application binaries that you need to run your application. So that means the base idea is to bring everything together that you need to run your application to get it started and run it successfully, but nothing else. And that one is put into an image, so you have kind of a template. The image has an immutable base, so when you start an image, you can't change the image itself, which is very important because that means that you always have the same environment when your application starts up. But then you can, of course, do things like add a file, change a file, delete a file, put something in a database or whatever. So the file system itself doesn't appear to be immutable, but technically behind the scenes, the base definitely is immutable, and you just have your changes that are put on top of it. What's also very important is that a container is not a VM. So especially you don't have a GUI to interact with a container. You can't connect to it using RDP. So that is something that I personally struggled a bit with when I got started. You really only can do things like remote PowerShell or SSH, or just open up a terminal inside of a container, but you can't connect to the desktop, so to speak, because the containers don't have a desktop. And an image also has a tag. That one is for versioning, and we will take a look at that in a second as well. Then some more things that I will mention. What is a Docker host? That is the physical or virtual machine where the containers are running. So basically you need an environment where your container can start. That might be your local laptop. It might be a virtual machine running on Azure, or it could be a physical machine if you still have one of those. Then we have a Docker registry. That is a place where you can get your images, or you can push your images. So if you define your own images for your own applications, you can push them to a registry, and then someone else can pull them, download them, and get them on their machines to start containers with it. And the most widely probably used one is the Docker Hub, because that one has a free registry, but there are also a lot of others like the Azure Container Registry. And then we also have Docker repositories. A repository is part of a registry. You can think of that one of something like a subfolder that is owned by a person or a company, and that contains the actual images. So you have kind of a hierarchical structure in here as well. So what do we do if we want to get a container up and running? The first thing that we want to do is we need to identify the image that we want to use. As I said, the image is basically the template for our container. So if we want to start a container, we need to say, okay, this is the specific image that I want to use. Let's say we want to use an IIS, then I would maybe use that one. You can see I'm pulling that one from a Microsoft registry, looking at a Windows Server Core image. That one has the name IIS, and then behind the colon, you can see Windows Server Core 2004. That is the tag that I mentioned before, which gives you kind of the version. There are also different ways to version an image, and we will look into more of that as well. But for now, let's look at that one. The second thing that you then need to do is you need to pull the image. So we would do a Docker pull to download the image to your machine if you don't have it. What that does is it takes a look at the registry and finds out if there is a newer version than you have locally, or if you have no version at all locally, and then it will pull that one to give you the latest version, or give you the version at all if you don't have it yet. The next thing then is that we want to create a container. That one is done using Docker create. Again, we give it the image name, and that one then will know what image to what image to use to create your container. And the last thing that we need to do is we need to start the container, and that one we can do with Docker start, and then we use the ID of the container that we just created. Now, those three steps that we just saw, Docker pull, Docker create, and Docker start, we can combine those into a single Docker run. What that does is it takes a look if you already have a local container, if yes, a local version of the image that matches the tag. If yes, then it will just use that one. If no, it will pull it. Then it creates the container and it starts the container. So typically you probably will just do a Docker run and the rest will happen automatically for you. So this is the base command that we will use to start up a container, and we will do that in a second. But the other thing that I want to share with you, because I think it's important to understand if you're using an Azure VM for that test, is how we can use or how networking works on containers. Because if we take a look there, if we are in an Azure environment, then we need to take care to be able to access the container. To give you an idea, as an example, I will again assume that we have a web server container. It might be the IIS that we've just seen, or it might be an Nginx or Apache or whatever. It actually doesn't matter. What we have here would typically be port 80 and port 443 for HTTP and HTTPS. So let's assume that our container has those ports open and is listening for requests there. As I said, the container is typically listening on a host. So we would have the container host around that one. And that means that we can't directly reach port 80 and 443 because we can only directly talk to the host. So what we do to solve that is that we can also have those ports open on the host. And those don't have to be the identical ports, but instead they can be different, and then we can make the connection. To show you that, I've used 8080 as a first example, and also 443 again for the HTTPS one, just to show you that it can be, but don't has to be identical. So if we now connect those, we basically tell Docker we want to have 8080 connect to port 80 in the container, and we want to have port 443 on the host connected to 443 in the container. Then we can use the command that you see below here. We tell it with the -p that we want to map ports. So we want to map port 8080 to 80 and 443 to 443, as I just mentioned, and we'll use the same IIS image. I've just removed that because there wasn't enough space. So if we then have a connection that connects to the host on port 8080, that one will take the request and know that it needs to forward that one to port 80. So if we do that, we have the direct connection from our host port to the container port, and the content will be served. Okay, so with that as a short introduction, I want to get us started on creating the Azure VM. So this is basically the first demo that I have created for you. And to give you an idea what I'm creating, this is really basically the most simple virtual machine that you can create on Azure. It is connected to a network interface. It has a virtual network. That virtual network has a network security group, if I remove myself from the image. It has a public IP, as you can see on the left, to be able to connect to it. And it has a setup script, which basically installs Docker, creates the Portainer container, and creates the Traefik container, so we can get up and running easily. How can you do that yourself? I'll switch to a demo here and show you how that works. First of all, I'll search for the Azure Quick Start templates over here, and then use the link, actually the first link for me that has a list of all the templates. My template is actually the only one that is using Portainer, so the easiest way to search for it is just to look for Portainer, and then you will find the Windows Docker host with Portainer and Traefik pre-installed. Just click on that one, and then you will get more information about what it does. You could also directly deploy to Azure. You can see the blue button here, but I'll move on to GitHub because that's where the sources are. So if you're interested in what is actually happening behind the scenes, you can just take a look here and find out what is in the scripts. For now, I'll just say deploy to Azure, which basically causes the same command that we've seen before. I need to log into the Azure portal, and then I will be presented with the template that asks me for some input. So you can see here it's the Windows Docker host. I'll create a new resource group for it, but I could, of course, also use an existing one. Say, OK, here, I'll use the region that I want to do. Let's use West Europe. And then I need to add an email address for Let's Encrypt. We will talk about that in a second as well. The next one now are the VM parameters. So I need to let Azure know what size my VM should be. The predefined one has 2 CPUs and 8 GB of memory. I can change that here. You have a list of all the most used ones. I'll use the 4 CPU, 16 GB, but as you've seen, there's a lot else. Then I'll enter the admin username and I give it a password. That password has some basic complexity rules, so it just can't be password or ABC123. And then we have the data disk. I'll use a smaller one for now, but you could also define a different size if you maybe have bigger images or want to deploy a big database or something like that. So now this is doing the deployment, and this takes around 10 minutes. Because of that, I've pre-recorded this, so I can fast forward here. And now you can see this is how it should look in the end. And we also get some output, which also contains the Portainer URL. So with that, I'll just do a right click and say, go to that URL. With that, I will automatically get the Portainer interface, so we can get started right away. The default user is admin, and it has the same password that we've generated for the VM administrator. So now I can say log in, and at the very first one, I need to select what I want to manage. In that case, a local Docker environment that is already pre-set up for me. So I can just click on connect, and now I'm done. I'm up and running. I can connect to that local interface, and I can already see some basic information. I can take a look at the containers. As I said, it comes with Traefik pre-installed for the networking and Portainer, which we are already using. So those have been pre-deployed by my script. We can also take a look at the host, for example, see the version, see the memory, see the CPUs, and so on. So we can get some basic information about what is happening here. So that is basically it. That's the start for us, where we have Portainer in place. We have the VM in place. We can get started. We can already connect. The next thing that I want to do is that I want to show you a bit more about what Portainer actually is doing and what we can use it for. As the very brief introduction, I've just copied the introduction from their website. It says that Portainer is a universal container management tool. You can use it with Kubernetes, with Docker, Docker Swarm, Azure container instances. So it basically allows you to manage a lot of the container workloads that you might have. And that is, in my opinion, a very useful thing, because if you get used to Portainer, you maybe get started on, let's say, a standalone Docker host, but then later decide to move on to Kubernetes or bring in Azure container instances or whatever, then you can still reuse the same management interface. You can still use Portainer to do all your management, to interact with your containers and make your life a bit easier, even if you're behind the scenes changing the technology. So let's see how that works. Let's see what else we can do with Portainer apart from the things that we've already seen. What we'll first do is, again, we'll take a look at the container list and then create a new container. To do that, you can see that we have a couple of inputs here. I'll paste in the name of the IIS container that we've seen before. So we will just create a web server, we give it a name, and then I could decide to publish all the ports to random hosts, run random ports on the host. But I need to have a bit more control. So in my scenario, as we've seen before, I'll add 8080 to 80. So 8080 on the host will give us a connection to port 80 in the container. Let's start that deployment. That one takes a couple of seconds until it's done. And now we already have our IIS container, which is up and running. So you can see here the name. You can find more information like the ID. You can see here that the port configuration has worked, so it's listening on 8080, and then we have a lot more information that we'll dig into in a second. What I now want to do is I copy the URL, put it in here, make HTTP instead of HTTPS, and put port 8080, because as you've seen, we made that connection and we try to now reach the IIS container. What you will see here is that it actually fails, and I wanted to show you this because that might happen to you as well. And the reason for the failure is that we didn't configure the network security on the VM to allow connections on 8080. So if we go to the Azure portal and go into networking here, then you will see that we basically have denied all inbound connections, which is the default on an Azure VM, and only allowed 443 and 22, but we also need 8080. So for that, we create a new inbound rule. The default already is 8080. I will have a bit more in a second, so I'm also adding 8081. And we allow basically all the traffic that is coming in. Just click on add. It's creating the security rule. That one takes a couple of seconds. It also sometimes already shows that it is here while it still doesn't work. So if it doesn't work immediately, then maybe you have to wait for a minute or two, and then it comes into play. So what we'll do here is we'll stop the loading and try again and refresh. And as I said, that one might take a bit until it kicks in, but it should hopefully soon appear. Yeah, here we are. Now we have our IIS starting page and have the connection available. So you've seen that we've connected 8080 on the host to 80 in the container. And you've also seen how easy it is to do that using Portainer. We didn't have to open up a command shell or anything. We just put the parameters in here and got it up and running. Now what I want to do is I want to get rid of it again, just to show you, you can easily remove it. It takes about 2 seconds and then it's gone. Now our container is gone again. We don't have anything that listens anymore. The next thing that I want to do is use a different image. So I copy that one in here. As you can see here, that's one of mine. I've called it sysinfo because it basically only shows a bit of system information. And I name it 4 because you can see here that one has version 4.0.0. Again, I'm connecting port 8080 to port 80 on the container because I know that something's listening here. And then I'll add an environment variable that is also an option to configure something that's widely used in containers. Let's say this is my production stage, and then add another environment variable. Global Azure is fantastic. So just to show you, if you come into the situation that a container asks for environment variables, this is the place in Portainer that you can use to create them. So my container already has been successfully created. Just to take a look again, it is up and running. It has the port definition that we've seen here, and it has the environment variables, the stage, and the global Azure one. So with that in place, we can just take a look. Again, this is still port 8080, but now no longer IIS is listening, but instead my sysinfo image. And you can see here it's version 4.0.0. And if I take a look at the data, the system information, you can see here the environment variable global Azure, and you can see that we have the production stage in here. So that one works as well, exactly like we assumed it would. So we are fine on that end. So let's get back to the container list and take a look at the other things that we can do here. We have access to the logs. So if you want to take a look at log of the container, which sometimes also can be interesting, that's easily done in Portainer. You can take a look at the stats. So you can see the memory consumption, 62 megabytes in that case, the CPU consumption, the network usage. You can see the processes that are running inside of that container. So you have kind of an overview of what is actually happening and the resources that are used by that particular container. We can also get a connection to a PowerShell or a CMD. That image doesn't have PowerShell, so I'm selecting CMD, and now I'm inside of my container. So this isn't the file system on my host, but instead this is the file system that you can see here and the terminal inside of the container. And that is sometimes when you need to run something in a container or take a look at something, that can be very useful as well. So let's go back in here and duplicate that one. So for example, I want to have a new version of my container. I just changed the name, I changed the version because I have created that image already, and the rest will just stay as it is. As the environment variable, let's say this is no longer my production stage, but this is my QA stage, and I can have this up and running. Deploy it, and we will run in an error message, exactly, because we've already used port 8080. So we'll switch that one to 8081. Again, try to deploy that one, and this time it works. So now we have our version 5 listening on 8081. If you remember, we also opened 8081 in the firewall of the Azure VM, so we should be able to connect to it. Let's give it a try. We still have 4.0.0 on 8080. Let's take a look at 8081, and you can see we have version 5 as we expected. If we take a look at the data, you will also see that we have now stage QA. So if that one needs to behave differently in the QA stage, show a warning, this is QA, this is not production, something like that, you can do that with something like this. So this gives us an easy way to have multiple containers running on the same VM and connecting to them by using the different ports, by having access through those different ports. But what I want to do is now I'll remove that one. So remove my two sysinfo containers, because I want to show you something else that is a stack file, basically a Docker Compose file. And if we say add stack here, give it a name. So we will basically deploy the same thing that we've just deployed manually by defining it as kind of a script. You can see here it's a YAML definition, sysinfo 4, the same that we've seen before, my image of version 4, the ports 8080 to 80, and the environment variable that this is the production stage. Then we have sysinfo 5, same image, but a different tag, also listening on a different port, and we have the stage QA. So with that, we already have defined our stack and we can easily deploy it. Again, this is doing nothing else than the manual steps that we've done before, but it is a bit more convenient if you have more different environments, if you have more different containers that you want to deploy. I want to make sure to show you that you can also do this using Portainer. So if you want to use a Docker Compose file for those stacks, there is no need to connect to the file to the PowerShell or terminal, but instead you can use Portainer for that one as well. So let's just take a look again on port 8081. We have version 5 as expected, and if we take a look at the data, this is the QA stage again as expected. If we go back to 8080. And give it a second, then we also have our production stage. So exactly like we defined in that Docker Compose file, version 4 on the production stage, that one is up and running as well. So we can easily use that, but to show you more how this can be useful, what I could also do is that I can take a look at the containers that are running in my stack. I can also say something like, I want to migrate or duplicate that one. So if I have different container hosts that I'm managing in here, then I could do that as well. Or if I just want to create a duplicate for testing or whatever, I can just select the endpoint, hit duplicate, and it would get duplicated as well. So this is also a very easy way to manage multiple containers at once. And I can go back into the editor and make changes here if I have a need to. So I could also say, now I want to have version 5 in my production environment, just make a change, hit update the stack, and then it would remove the version 4 container and replace it with a version 5 container. I can also create a template. Now this is something that Portainer brings with it. Docker Compose is something that comes with Docker, but the templates is a specific Portainer feature. I could use this, say it's based on Windows, and then I have the same file easily definable here, and say create that as a custom template. And that means that I have an easy GUI here as well to deploy that one. So if I remove that one and assume that I have a new Docker host that I'm now connecting, I want to deploy my sysinfo stack, I could either use it manually, I could use the GUI that we've seen before, or I could use the templates because we now have created that template. I'll just click in here, say this is my sysinfo stack. I can customize it if I want to, and then just deploy it easily. So this is also a very neat feature if you want to share those informations, that stacks with others in your team or with your customers or something like that, and you can use those templates to make sure that they are well configured, it's the right version, it's the right setup, the right environment variables, and all is as it should be. So again, we have our containers, they are started version 5, version 4 with the environment variables that we expect. Okay, so that should give you an idea of how Portainer works, what you can do with Portainer. Just to validate, let's take a look again. On port 8080, we have version 4. On 8081, we have version 5, just as expected. Actually, those are only the basics that we've seen using Portainer. You can do a lot more with it, but to get you started, again, to give you an idea of what you can do in Portainer, that should hopefully be enough. So if you want to get started with Windows containers, you know where to look and what things to do over here. With that, let's move back to the presentation. So as I said, we've seen Portainer, we've seen the basics for Portainer. The last thing for today is that I want to show you how we can use Traefik as a reverse proxy to make the management of those containers and the network connection to those Portainers even easier. That's basically the mantra of Traefik. Traefik Labs, the company behind Traefik, make networking boring. It's really the idea that the trouble that you sometimes have with networking is no longer happening, but instead it's very easy to use, it's very easy to understand what is happening and so on. Okay, so let's take a look what the basic idea is, and this is only one of a lot of scenarios that you can do. Traefik really is very flexible. It's a very it can be very complicated, or the scenarios that you can implement it with can be very complicated. Traefik itself usually is very simple to understand, but I want to show you one of the most easy to understand scenarios so you have kind of an easy start into Traefik. Let's assume we have our container host, our VM, and we have 2 web server containers. Same that we've just seen, web server container 1 listening on port 80 and web server container 2 that is also listening on port 80. Now we've seen if we want to make those available to the external users, we would in Docker typically use different ports, but that can be cumbersome. If you imagine we don't have 2, but we have like 20 or 30 or whatever containers on that one, it can be difficult to keep track in your firewall, let the users know which ports they need to access to and so on. So there are easier ways, and Traefik can be one of those that makes it easier for you. So what we can do is we make port 443, and now this time, because we can also easily enable SSL externally available, and Traefik is listening to that one. As you can see here, Traefik is not something that you install on the host typically, but instead it's also a container that is running and talks to the other containers. And what it can do is that it has a rule like this. So if a request comes in which has the host and then /c1 as part of the path, then it will know to redirect you to container 1 on port 80. Those rules are not happening automatically, but instead you need to define them. But as we will see in a second, it's very easy to define those rules and make sure that the right connection is happening when the request comes in. So if now someone opens a browser, connects to the host /c1, it will connect to port 443. That one will connect to the Traefik container. Traefik will take a look at the rules and decide, okay, I know what to do with the /c1 request. I need to connect it to the web server container 1 and need to connect it to port 80. And that way, if that request comes in, we have a connection. So without any further additional theory, let's get started again with the actual practical usage of Traefik. What we can do now is that we take a look at our containers again. And as you can see, we already have Traefik installed as a container. It's used to access Portainer as well. And I can show you here how it works. The first thing that we need to do is we need to let Traefik know that we want to be the container available. So we have the first thing here that says Traefik enable is true. Then we have a couple of other things, including that particular rule that knows if a request comes in for that particular host and on the prefix /portainer/, then it will be redirected to this one. So what we can do now is if we go back into our stack where we didn't use Traefik before, we can modify that one to use Traefik. We don't no longer want it to listen on a particular port, but instead we just define a couple of labels, including the one that tells Traefik that this is a container that Traefik should be interested in. So we just set Traefik enable to true. The next thing that we do is that we need to let Traefik know that it is connected to this particular instance, sysinfo4. Then we need to let Traefik know where to connect on the back end, port 80, and it doesn't need to be HTTPS, but instead HTTP. So we're letting Traefik know that information. And then the last thing that we do is that if a request comes in on a particular suffix, and I'll show that in a second, and connect that one to sysinfo4, then we want to make that connection. So you've seen here that this has a suffix. I'll just replace that one with the name over here. That's just for me to make it easier to handle. So now we know that if a connection comes in on that particular host and it has that prefix in the path, then it will make that connection. The last thing that we need to let it know is that if something comes in through a specific entry point, we only have one, but let's have it as well, then we make that connection. And we let the application know that it needs to listen on the sysinfo4 subpath, because previously it was listening on root. Now it needs to listen on sysinfo4, so we have that as well. And we need to connect it to the same network where Traefik is already running, so Traefik knows how to connect to that one as well. So this is basically our setup for the production environment. I'll just copy in the same for the Q&A environment. That one has sysinfo5, it has version 5, it's connected to the sysinfo5 service. The path is sysinfo5, but basically it's the same that we've seen before. It's connected to the QA stage, and again, it's running on the sysinfo5 prefix. So let's say update the stack. And that one will remove the existing containers with the port-based configuration and replace it with that configuration that uses Traefik. So we now have successfully updated it. Let's take the same URL, add a /sysinfo4, and you can see that we're now connected to the container on with version 4. If we take a look at the environment variables again, we still have the production stage in here. So you can see that it has made the connection. It has made the rule using Traefik, and I missed something for sysinfo 5. Let's take a look again. No, this is for, no, the host. You can see here I missed to replace my suffix. So let's go back in again into the stack and edit it, copy the suffix in here and update again. So now it's only replacing the sysinfo 5 container because the other one was already right. Let's see and go back in here, connect to sysinfo 5, do a reload, and let's see if it loads. Yeah, now we have sysinfo 5. That one is our QA stage. And if we go back to the home page, you can also see that this is version 5. So now we are fine. We have that connection as expected, all handled through Traefik. And as you can see here, there's no need to let the users know anything about ports or that. We have nice URLs that we can use and give the users. So we have a nice distinction between the different versions and so on. So it's a lot easier. You don't need to worry about any hosts. You've also seen that we automatically get HTTPS support. So it's also more secure that way, and it's a very easy setup, as you've just seen. So this already brings me to the last part for today, which is how we can do troubleshooting when we're using Traefik. For that, oh, sorry, that was too quick. For that, we will use the IIS image again. So I'll go back in here. As you can see, we still have the same environments up and running. What you need to do to take a look at the troubleshooting that I show you now is you need to make sure that the Traefik container itself is also enabled for Traefik. That is false by default in my VM because it's a bit unsecure to do, but for testing or debugging purposes, that still can be fine. So for that, we will access /dashboard. That one is automatically created by Traefik, and you can see here that we have an overview about the configuration. You can see the web secure endpoint listening on port 443. You can see we have the different routers, we have services, and we have middlewares. We have 4 routers in here. If we click on explore, then we can find more information. You can see here that we have the sysinfo 5 router, so that one knows what to do with that request. The sysinfo 4 one, Portainer, and then we have the API and dashboard that is automatically defined by Traefik itself. So that is kind of the rules that we use to make connections to our services. You can also see the services where each of those is connected to. So if you have maybe a typo or any other issues, you can easily find out by using that one. Now, if we go back to the starting page, sorry, that is actually the GitHub repo. I wanted to go back to the dashboard. As I said, we have a couple of services. We can take a look at those as well. You can see here how much connections they are, what the provider is, so what is created by a Docker container and what is coming directly from Traefik and so on. And we have middlewares, which you can see here, one that does strip a prefix, as you can see here, and one that is doing buffering. So that one is, for example, used to define what the maximum request size is when going through Docker. And here is the strip prefix. That means that if a request comes in on /Portainer, that /Portainer is removed. So it is just redirecting that one for Portainer. Again, this is just to give you an idea. Yeah, here's the rule. This is just to give you an idea how you can take a look at the configuration. It can be, especially if it gets more complicated, it can be interesting to just take a look and find out how Portainer interprets your configuration, and that's a good way to do that. Okay, so if we now add an additional stack to give you one more ID, let's use our IIS again and put that in place to show you how the prefix stripping works. I'm using the IIS image again that we've seen in the beginning. It's enabled in Traefik. It is using the IIS service, listening on port 80 and HTTP, and it has a prefix of /IIS. So you might think that this is fine. This should work. Let's deploy the stack. And actually creating the container and interpreting the configuration works well. But if we take a closer look now and try to connect, we go in here. If you remember, the rule was /IIS, so I'll add that one here. You can see that we have an error. Maybe you can already identify it by the way it looks that we've indeed connected to IIS, but something is not working. And the reason for that is that we still have /IIS, and IIS doesn't know what to do. So the container is still getting the request /IIS, as you can see here. But it instead is listening on root. So there's nothing that is answering on /IIS. What we can do for that is add a middleware like we've just seen. In that case, it would be the strip prefix middleware, as you can see here. So whenever a request comes in, it will remove the /IIS. And we say that the middleware IIS Docker is connected to that one. So we let it know that if a request comes in here and it matches the rules, then it should apply that particular middleware to remove the IIS prefix. So if we deploy that one again, it's still the same image, it's still the same version, basically the same configuration, but we've added the strip prefix. And if we now reload here, you will see that we end up on the starting page. Because now the middleware has removed the /IIS prefix and we're back into the root of the container and we're fine and can connect to that one. Okay, so that basically was my content for today. That would be the moment where I'll ask if there are any questions. Let me check the Q&A in Teams. There is nothing. So if you have any question, feel free to ask. I know it's like a 15 or 20-second delay between me and the streaming, so it might take a second for anything to appear. But if not, also feel free to get in touch. You've seen the contact information in the beginning that you can use to connect with me. I'm always happy to have any discussions on containers, Portainer, Traefik, whatever. Just get in touch and let me know. So with that, I'll want to end it for now. Thank you for listening. Thank you for participating in that session. If you have any feedback, also feel free to let me know. And of course, keep learning with Global Azure. Have fun with the further sessions. I'll also do another one in 3 minutes. So at 3 o'clock, I will do more of a deep dive into Traefik and how that one works. But also, of course, have fun with all the other sessions that are presented at Global Azure. So again, thanks a lot for your time. Thanks a lot for listening, and I hope to get in touch.